So, we rely on AI for some pretty big decisions, right? But what happens when that AI is just wrong? Deceptively wrong? Well, today we're going to dive into some fascinating research that's found this incredible defense system hidden right inside our own brains. A secret veto, if you will.
You've probably heard of this idea, right? The wisdom of crowds. Think about the classic jelly bean jar contest. One person, they might guess way too high or way too low. But if you average out 1,000 guesses, it's often shockingly, spookily accurate. And this idea gets used everywhere, from the stock market to how teams make big calls.
Okay, but here's the key, the secret sauce to the whole thing. That magic only kicks in when everybody's thinking for themselves. All those little mistakes are random, so they just cancel each other out. But what if you mess with that independence?
Let's go back to that jelly bean contest. Now imagine a saboteur, right? Someone whispering the exact same wrong number into every single person's ear. All of a sudden, their independent judgment is totally corrupted by the same piece of bad info. The crowd's wisdom doesn't just vanish, it flips on its head. It turns into a catastrophic collective failure, and that is the exact vulnerability we're facing right now with human AI teams.
So let's really dig into this problem. Because when we team up with an AI, we're basically creating a situation where a single, flawed algorithm can trick an entire group of human experts into making the exact same mistake, all at the same time.
This has a name. It's called correlated error, and it is the Achilles heel of human-AI collaboration. It's a huge deal. See, instead of individual mistakes just canceling each other out, the AI forces everyone down the same wrong path. The errors don't cancel out, they stack up, they amplify, and they lead a whole team to be super confident and super wrong.
Okay, so to really see how dangerous this can be, some researchers set up this really high-stakes experiment. They basically designed a situation to make these human AI teams fail, just to see if there was any way to protect them.
All right, so here's the setup. You've got people in a VR simulation playing the role of drone operators. Their job? Spot enemy targets in a really stressful environment. Think dark, low light, high pressure. And they have a helpful AI that's supposed to highlight potential targets for them. But, and here's the big catch, on the really tough trials, the AI was programmed to lie. The real goal here was to see if a brain-computer interface, or a BCI that was reading their brainwaves, could actually see through the AI's deception when the humans couldn't.
So, the stage is set, right? You've got a team of skilled operators, super high-pressure conditions, and a trusted AI partner that is actively trying to mislead them. What do you think happened? How do you think they did?
Well, the results weren't just bad. They were a total, catastrophic collapse of every traditional way we make group decisions.
I mean, look at this. The difference is absolutely staggering. The teams that just used a simple majority vote, their accuracy plummeted to 44%. They were wrong more often than they were right. But the team that was guided by the BCI, get this, 98% accuracy. That's the difference between complete mission failure and near-perfect performance. It's just, wow.
And this table really drives the point home. It shows just how incredibly resilient that BCI was. While the standard methods, like majority vote, or even just asking people how confident they were, saw their performance drop by over 50%, the BCI-only team's performance, it barely even budged. It was almost totally immune to the AI's lies. So, how in the world is that even possible?
Well, the answer is in this really fascinating disconnect between what our conscious mind thinks is happening and what our brain is actually doing. There's a term for this. It's called neurobehavioral decoupling. And what it means is this. Even when a person was completely fooled by the AI, even when they confidently went to press the wrong button, their brainwaves were going crazy. They showed this flurry of activity that signaled conflict and doubt and uncertainty. It's like a part of their brain knew something was wrong, even when their conscious mind was totally convinced. It's like this internal alarm bell that only the machine could hear.
And that is the secret weapon here. The BCI wasn't listening to the person's final, confident decision. No, it was tapping into that raw, unfiltered brain activity that happened before they ever even pressed the button. That pre-decision signal was totally insulated from the AI's bias, and it gave a pure, honest look at the situation. Okay, but it gets even smarter than that. The BCI didn't just find one magic signal, it actually learned to recognize two totally different mental states or strategies that the brain was using to solve the problem. So, on the easy tasks, the brain went into what you could call an autopilot mode. And here, the key signal of a correct decision was actually the absence of hard thinking. It was quiet efficiency. But when that deceptive AI threw a wrench in the works and created conflict, the brain switched into active struggle mode. In this state, the BCI learned that the most reliable signal was intense cognitive work, the brain literally fighting against the bad information. So it could tell the difference between, yeah, I've got this no problem, and whoa, something's not right here. I need to figure this out.
And what's just incredible is that the BCI could track both of these strategies by focusing on one single critical spot on the head, F9. It's right over the prefrontal cortex, the part of our brain that handles all the big stuff like decision-making and sorting out conflict. So a quiet signal from F9 meant autopilot, all clear. But a noisy, high-energy signal, that meant active struggle, and it showed the operator was correctly fighting back against the bad AI.
So what does all this mean for the future? I mean, this is way more than just a cool lab experiment. This is pointing towards a powerful new kind of safety system for human AI teams out in the real world.
Just think about the applications here. You've got drone pilots, intelligence analysts, medical teams. In all these fields, an entire team of experts could be led down a dangerous path by one single flawed AI suggestion. This BCI could be like a cognitive safety net. It could detect that hidden struggle inside the team's brains and flag a decision for review, even when every single person on the team says they're 100% confident.
What this system really does is create what you could call an implicit dissent channel. It gives a voice to that little part of your brain that's screaming something is wrong. It can sound the alarm when there's a dangerous mismatch between how confident a team says it is and what its brain activity is actually showing. It could prevent those catastrophic errors before they even happen.
And that really leaves us with a pretty big thought. As we build more and more powerful AIs to help guide our decisions, it's possible that our ultimate fail-safe, the final line of defense against their flaws, won't be another fancy algorithm. It might just be a deeper connection to the quiet, intuitive wisdom that's already inside our own brains.